You are listening to The Vocal Technologist. Spoken tech for your ears.
Welcome back. You know, the speed things move in tech today, it's really something else, almost dizzying.
It really is. It feels like you blink and there's a whole new stack, a new vulnerability, a new way of doing things,
Yeah,
especially in DevOps and development.
totally. And trying to keep up, well, it's a full-time job in itself. So what we want to do today is cut through some of that noise. We've got some great material here covering security, big system failures, new protocols.
Right. The goal is to pull out the really useful bits, the stuff that actually helps you understand what's shifting under our feet.
Exactly. This is kind of what we aim for here at Vocal Technologists, giving you those practical takeaways. Today, we're really looking at how we're handling, more complexity and the demand for more speed. Seems like a contradiction sometimes.
It often is. But that's where new tools and architectures are trying to bridge the gap. And actually, the way different parts of our systems talk to each other, that's seeing some big changes right now.
Okay, let's start right there at the connection layer. We've had the whole REST versus GraphQL debate for years, right? But now Cloudflare's thrown something new into the mix. Captain Web, it's a lightweight RPC system based on TypeScript. What's the deal with this? What makes it different?
Well, the core idea behind Captain Web is pretty neat. It tries to make calling a function on a remote server feel just like calling a local function in your code.
Yeah.
It sort of smooths out that network boundary feel.
Okay, how does it do that? Making network calls feel local sounds ambitious.
Yeah, it's got a couple of key things. First, it supports bidirectional calls. So the client can call the server, and the server can call back to the client. Really useful for real-time stuff, like collaborative apps.
Right, like Google Docs or Figma, that kind of interaction.
Exactly. But the really different part is how it handles data. It lets you pass functions and even objects by reference across the network.
Whoa, hang on. By reference across the network? Isn't that dangerous or just complex?
It sounds it, but it's combined with something called capability-based security. So instead of sending, like, the whole chunk of data back and forth, you're just passing a secure pointer, essentially. And the caller only gets permission to do specific things with that pointer.
Ah, I see. So it's not wide open access.
No, definitely not. It means you can interact with remote resources, almost like local ones, without the overhead of constantly serializing and deserializing big payloads or defining massive GraphQL schemas for every little interaction. It's a strong alternative, especially where that back and forth collaboration is key. It's a conceptual shift, thinking of endpoints more like objects.
Interesting. Okay, so that's simplifying the connections. What about simplifying the beast that is the infrastructure itself? I mean,
Sure.
Kubernetes.
Yeah.
Powerful, yes. Painful. Also, yes. How are people getting a handle on K8's complexity?
The big trend, the term you hear everywhere, is the golden path.
Right, the paved road.
Exactly. It's about platform teams building these standardized, highly automated workflows. So developers don't start from a blank slate. Security is baked in, observability is baked in, the CI/CD pipeline is ready to go.
But doesn't that take away flexibility? What if a team needs something off that golden path? Are they stuck? Does it become a bottleneck?
That's the balancing act, absolutely.
Yeah.
It's a valid concern. The path needs to cover, say, 80% of the common needs really, really well. And going off path should be possible, just maybe require a bit more justification or effort.
Okay.
But the huge win here is developer experience DevX. Developers aren't wrestling with YAML files and network policies nearly as much. They could just build features. And that speed translates directly to business agility. Less time fighting the platform, more time delivering value.
Makes sense. And underpinning a lot of this modern cloud-native stuff, there's this tech that feels like it's everywhere, but maybe not fully understood by everyone. eBPF. Why is eBPF such a big deal? Why is it called foundational for, like, Cloud Native 2.0?
eBPF. It's kind of like the secret sauce in the kernel. Imagine you could safely run little custom programs inside the Linux kernel itself without having to recompile the kernel or even reboot.
Okay.
That's basically what eBPF lets you do, and the implications are massive. It means you can do incredibly fast networking tricks, deep system observability, fine-grained security monitoring, all right at the kernel level.
Without the clunky stuff we used to use, like sidecars.
Exactly. No need for bulky sidecar containers injected into every pod, or installing special agents everywhere that add overhead. eBPF can often do the same job, but much more efficiently and less intrusively. It's quietly revolutionizing how we build and monitor cloud infrastructure.
Got it. And sometimes it's the small operational wins that make a difference too. Like in Kubernetes 1.34, they made automated recovery for persistent volume claim PVC expansion failures generally available. Why does a detail like that matter?
Oh, that's a lifesaver for operators. PVCs are how your stateful apps, like databases, store their data in K8s. If you try to expand one, give it more space, and it fails, maybe the storage system is temporarily dizzy or whatever.
Yeah, that used to be a manual fix, right? Probably during an outage.
Right, exactly. Now Kubernetes can actually retry that expansion automatically.
Yeah.
And crucially, it does it at a slower rate if it failed the first time, so it doesn't hammer the storage system. It turns a potential late-night panic into a background self-healing event. Small change, big impact on reliability. Okay, shifting gears a bit, let's talk security. Because there's a whole new can of worms opening up with AI agents.
Yeah.
The Model Context Protocol, or MCP, is emerging as a standard way for these agents to connect to tools and data. But wow, the risks are serious.
Yeah, I can imagine. You're basically giving code driven by potentially unpredictable LLM output access to, well, anything, right? What are the big threats people are worried about?
You nailed it. It's things like command injection. The agent gets tricked into running malicious commands. Classic prompt injection, of course. But also just simple misconfigurations where an agent gets way more permissions than it needs. And, naturally, supply chain attacks. If the agent uses a compromised tool, game over.
So it's like giving an intern root access and hoping for the best.
Uh-huh. Kind of, yeah. It's a high-privilege process running dynamic code based on external input. You absolutely have to lock down its environment.
So how are we doing that? What are the defenses?
Well, companies like Docker are pushing a layered approach. First, run the MCP server itself in a container, obviously. Isolate it. Then put a policy enforcing gateway in front of it.
Okay, like an API gateway, but for the agent?
Pretty much. It controls exactly which external tools or APIs the agent is allowed to even talk to. And they're also pushing the idea of a curated catalog and toolkit, basically, an allow list of pre-vetted, safer tools the agent can use. It's all about standardization and tight boundaries.
Control those boundaries, because if you don't, things can get scary fast. Which brings us to that MCP Inspector vulnerability, the debugging tool. Tens of thousands of downloads, critical CVE. Walk us through that one. CVE 2005-49596, a 9.4 CVSS score. What does 9.4 mean in practical terms?
A 9.4 CVSS score is basically screaming, patch this now W. It's critical, easy to exploit, potentially devastating impact. And this one, it was down to a really subtle, fundamental misunderstanding of network basics.
What was the actual flaw?
It was how the browser interpreted the IP address 0.0.0.
Okay, 0.0.0 usually means listen on all available network interfaces, right, for servers wanting external connections. How is that a flaw?
Right, but localhost, or 127.0.91, means only listen for connections from the local machine itself. The problem was, in this specific browser implementation used by the inspector tool, it mistakenly treated 0.0.0.0 as being the same as localhost.
Wait, what? How does confusing those lead to a critical remote attack?
So imagine a developer is running this MCP Inspector tool on their machine, maybe debugging something, it's listening, possibly on 0.0.00. Then they just visit a malicious website.
Okay.
Because the browser thought 0.0.0.0 was the same as localhost, that malicious website could send commands directly to the inspector tool running on the developer's machine, bypassing normal security boundaries. It could talk to the tool as if it was the local machine.
Oh, wow. So drive-by attack, essentially. Just visiting a web page could let an attacker interact with local tools and potentially access private files.
Exactly that. Access developer keys, private code, anything the tool could reach. It's a chilling reminder that even foundational network assumptions can sometimes be wrong in new contexts.
That is genuinely terrifying. Okay, so defense. Let's talk proactive defense. Supply chain is often the weak link. How do we get better at managing dependencies? What's this less is safer idea?
Yeah, the way Obsidian handles dependencies is kind of the gold standard for careful paranoia. Step 1, just use fewer third-party libraries. Be really critical about adding anything. Step 2, strict log files, obviously. But crucially, they have slow, really review-heavy processes for updating dependencies. They deliberately delay pulling in the latest versions.
Delay updates, isn't that counterintuitive for security patches?
It seems like it, but the idea is to let the wider community find malicious packages first. If a bad version gets published, hopefully someone else flags it before Obsidian pulls it in. Slow is safe.
And the absolute must-do.
No post-install scripts, ever. Those scripts run automatically when you npm install something. They're just a wide open door for attackers. Disable them, block them, don't allow them. It drastically shrinks your attack surface.
Right. Okay, one more defense topic. Bots. Scraping bots, attack bots. They're getting smarter using AI themselves. Cloudflare rolled out a new per-customer ML detection system. Why the need for customer-specific models?
Because the generic approaches weren't cutting it anymore. Attackers use AI to mimic human behavior so well that generic bot scores were missing sophisticated scraping.
So one size fits all doesn't work.
Not against advanced threats. By training unique ML models on the normal traffic patterns for each specific website, Cloudflare could spot anomalies much better. Their validation showed it flagged 34% more malicious scraping requests that the old system completely missed. You need tailored defenses for tailored attacks.
Okay, so we've talked architecture, we've talked security, but things still break, right? Failure happens. What matters then is how fast you recover, and maybe more importantly, how fast you learn. I was really interested to see Netflix shifting how they handle incidents.
Yeah, that's a big cultural shift. They're moving away from having a central SRE team be the bottleneck for all incident management.
Pushing it out to the engineering teams themselves.
Exactly. They adopted tools like Incident.io, integrate them tightly with Slack and their internal systems. The goal is to make it easy and intuitive for any engineer whose service is having issues to declare an incident, manage the response, and run the postmortem.
So it's about democratizing that SRE skill set.
Pretty much. It reduces the bus factor. What happens if the main SREs are unavailable? And it builds ownership.
Right.
Plus, having lightweight, consistent processes across the org means everyone learns faster from failures, not just a small central team.
And that learning piece. The post-mortem, that's often the hardest part, sifting through logs, trying to find patterns. It's time-consuming. AI seems like a natural fit there.
Absolutely. Zalando's use case is fascinating. They trained an LLM, basically an SRE assistant, on thousands of their past incident postmortems.
Okay, what could it do?
It could analyze all that text incredibly quickly, cutting down analysis time from days to hours. And it started spotting recurring patterns, these hidden hotspots, particularly in their Postgres, DynamoDB, and Elasticsearch usage, that human analysts had missed just because of the sheer volume of data.
Wow, and finding those hotspots actually led to changes. What was the impact?
Huge impact. Based on the LLM's analysis, they implemented specific preventative measures, like automated validation for infrastructure as code changes related to those data stores. And that single set of fixes has prevented about 25% of potential data store incidents since then.
That's significant.
It really is. Now, they emphasized human curation is still essential. You need humans to check the LLM's findings, filter out noise or hallucinations. But the speed and scale of analysis unlock real preventative wins.
And we're seeing AI helpers pop up in day-to-day developer tools too, right? Like Grafana Assistant.
Yeah, exactly. Tools that can help you write complex monitoring queries, or explain what a weird log message means in plain English, or even help build dashboards. It's all about lowering the friction for observability and operations, making it easier for everyone, not just the experts.
Okay, before we wrap up, let's quickly nail down something that trips people up. AWS Data Movement Services, there's SQS, SNS, EventBridge, Kinesis, MSK. It's a lot. Can you give us the super quick, like one-sentence guide for each type? When do you use queues versus buses versus streams?
Okay, quick cheat sheet. Think. Queues like SQS are for decoupling. One system puts a message, a task in the queue, another system picks it up later. It ensures work gets done eventually. Pull-based.
Got it. Queues decoupling tasks. What about buses?
Buses like SNS or EventBridge are for broadcasting events. One thing happens, and you want multiple other things to react immediately. Push-based, event-driven. Think fan-out.
Okay. Buses, event broadcasting. And streams.
Streams like Kinesis or Kafka, MSK, are for high-volume order data flow. Think ClickStream's IoT data. The order of events matters, and you often want to process a continuous flow of related data points. It's about processing sequences.
Perfect. Queues decouple tasks, buses broadcast events, streams process ordered flows. Much clearer. Hashtag tag outro. All right, that brings us to the end of quite a journey through the current tech landscape. We covered a lot from Captain Web, changing how we think about RPC.
To the discipline needed for Kubernetes' golden path, the scary subtleties of that Mort 0.0 bug.
And that crucial push towards really learning from incidents, maybe even with some AI help.
Yeah, and it all ties back to that core challenge in DevOps, right? How do you get faster and more agile, but do it safely, securely, and on systems you can actually understand and observe?
Absolutely. And, speaking of learning from things, I saw this fascinating stat from Spotify about their experimentation platform. They found their win rate experiments that actually shipped a measurable improvement is only about 12%.
Only 12%? Wow, that seems low.
Right. But here's the kicker. They're learning rate experiments where they gained valid information, maybe learned what not to do, or detected a problem that was around 64%.
Ah, okay. That tells a very different story.
It really does. It highlights that most of the value isn't necessarily in the outright successes. It's in systematically understanding the failures, the regressions, the things that didn't work out as planned.
If you're only celebrating the 12%, you're missing the bulk of the insight that could actually drive future improvements.
Exactly. So maybe the final thought to leave everyone with today is this. If your organization isn't really tracking its learning rate, how do you know if your inevitable failures are actually making you smarter? How do you know if they're productive?
That's a really good question to ponder. Food for thought.
Indeed. Well, thanks for digging into all this with us today.
My pleasure. Always interesting stuff happening.
For sure. Thanks, everyone, for tuning in, and we'll catch you next time.
Spoken Tech for your ears.